Good morning, students of LS and GS. In this video, we are going to explain the second part of the chapter of radioactivity. The objectives are: define the decay constant, define the activity of radioactive element, define the period of radionuclide, state the laws of radioactive decays, and solving some problems. First of all, let Anzio be the initial number of a nuclei that was present at t equal 0. Let n be the remaining number of nuclei at any instant t. We have dn over n, which is the derivative of n with respect to n equal minus lambda dt, where lambda here it differs from in case or it is not the wavelength, it is called here the decay constant. Its unit is per second. First formula, this formula admits without any proof n equal n0 exponential minus lambda t. N, it is the remaining number of a nuclei. N0, it is the initial number of a nuclei, and lambda, it is the decay constant. N disintegrated or N lost is equal to N initial minus N remaining. Period or half-life. From chemistry, the period of half-life of a radioactive substance, it is the time needed for which the number of a nuclei to become half its initial value, or it is the time needed for which the mass becomes half its initial value. By replacing T equal to capital T in the equation N equal N0 E minus lambda T, we said that N equal N0 over 2. This means that N0 over 2 equal N0 exponential E minus lambda T. We get that 1 over 2 equal E minus lambda T. This means that minus ln 2 equal minus lambda T implies T equal ln 2 over the decay constant. Here, this formula admits without any proof. First, here, up to here, we speak about two formulas: n equal n0 e minus lambda t, n disintegrated is equal n lost equal n initial minus n remaining, and the period equal ln 2 divided by decay constant, or decay constant equal ln 2 divided by t. Note here that the period depends only on the decay constant, so it depends only on the kind of radioactive substance. If we take the formula T equal N capital T, where T it is any time, N it is the number of periods, and capital T it is the period, we get N equal N0 E minus, substitute instead of T small t and capital T. This means that n equal n0 into 1 over 2 to power n implies n equal n0 over 2 to power n. Also, this formula admits without any proof n remaining equal n initial divided by 2 to power n. For this, we have the remaining number of a nuclei equal initial number of a nuclei n equal n0 e minus lambda t. Also, n disintegrated it is equal n disintegrated equal Anzio minus n, and the third law here is n equal Anzio over 2 to power n, where small n it is the number of decays or the number of half-life. Activity. The activity, this must be memorized definition, we must know it. The activity of radioactive sample represents the number of disintegration or decays per unit time. It is activity equal number of disintegration over time. Or we can say that the activity equal lambda times n, where A, it is the activity, its unit in pcool or pq, lambda decay constant, and n, it is the number of nuclei. How to find the other formulas of activity? First of all, n equal n0 e minus lambda t. And if we multiply by lambda, this gives that lambda n0 exponential equal lambda n0, it is equal a0. This means that a equal a0 e minus lambda t. Also we can set that a0 equal lambda n0. Also, similar to n equal n0 over 2 to power n, we can say that a equal a0 over 2 to power n, where a0 it is the initial activity, a it is the remaining activity. Also, we can set that the mass remaining equal mass initial exponential minus lambda t, or the remaining mass equal mass initial over 2 to power n. Summary of this video. First of all, we said that n equal n0 exponential e minus lambda t, or n equal n0 over 2 to power n, where small n it is the number of periods. Also t equal n capital T, n lost or n disintegrated is equal n initial minus n final. Also decay constant, it is equal ln 2 over capital T, where capital T is the half-life or the period. Activity, it is the number of decays per unit time. Activity A equal lambda n, A equal A0 e minus lambda t, A equal A0 over 2 to power n, and A lost equal A initial minus A. Also, in a case of mass, we can set that mass remaining equal mass initial E minus lambda t, or mass remaining equal mass initial divided by 2 to power n, or the mass lost equal mass initial minus mass remaining. I am going here to solve some problems from the book. Here I am going to solve problem number 6. This problem said that the period of an isotope is equal to 1 month. Would a given sample of this isotope decays in 2 months? If not, what is the quantity remaining? First of all, since the period is 1 month, after 2 months we have the substance is not totally decayed, because if we apply the formula T equal n capital T, this means that the small n it is equal to 2, n remaining equal n0 over 2 to power n equal n0 over 4. This means that m lost or m disintegrated it is equal m initial minus m remaining equal 3 over 4 and 0. Question number 7. A couplet 60 27 nucleus is in an excited state, emits gamma rays of 1.33 mega electron volt when decayed to the grounded state. Its mass in the grounded state is equal 59.93382 U. Calculate the mass in the excited state. First of all, the liberated energy E equal delta M times C square. Here, E liberated, it is the E of gamma, it is 1.33 mega electron volt equal delta M times 931.5 mega electron volt divided by C square times C square, then the mass will be 0.00143 U. We know that delta M equal M of the reactant minus M of the product. It is equal also M excited minus M grounded. This means that M excited equal M grounded plus delta M. It is equal 59.93535 U. Question number 8. The period of radioactive substance is equal to 140 days. How long does a sample of this isotope take to lose 3 over 4 of its initial value? In this problem, T equal 140 days. And lost equal 3 over 4 Anzio. This means that N remaining equal N0 minus N lost equal N0 over 4. The formula is N equal N0 over 2 to power N equal N0 over 2. This means that N it is equal to 2. Knowing that time equal N times the period equal 2 times 140 equal to 80 days. After 38, 30, problem number 9, after 36 hours, the activity of the sample becomes 1 over 8 of its initial value. Determine its period. First of all, T equals 36 hours. A equal A0 over 8. We have to find the period. First formula, A equal A0 E minus lambda T. This means A0 over 8 equal A0 E minus lambda T implies 1 over 8 equal E minus lambda T. Ln both sides, ln 1 over 8 equal minus lambda T implies lambda equal 0.057 per hours. To find the period here, we write that the period capital T equal ln 2 over lambda. Problem number 10. Carbon 14-6 isotope has a half-life of 5730 years. At a certain instant, a sample contains 10 to power 22 nuclei of carbon 14. Determine its activity. First of all, activity it is equal decay constant or times n. Here, decay constant equal ln 2 over t. But we must remember here that we must change t to second. 5,730 times 365 times 24 times 3600 because the 1 year is equal 365 days, 1 day equal 24 hours, and 1 hour equal 3600. This means that decay constant equal 3.83 times 10 to power minus 12. Also, A equal lambda times n. This means that lambda equal 3.83 times 10 to power 10 p cubed. Thank you.